Hi everybody, I'm Shelton, and I'm here to share some interesting facts about space with y'all today. We go outside every night and we see the stars, and if you gaze long enough, you're often left wondering what might really be out there. Space has always been one of the universe's great mysteries, and while it is a very large mystery, we have discovered some very interesting things about it. And I don't claim to have a PhD in space or anything, but I'm a very avid space lover, and I've done my research over the years because it's truly fascinating to me. Today I'd like to share with you about black holes and time relativity. And first we're going to start with black holes. You might be wondering what a black hole is. NASA defines a black hole as a region in space where the pulling force of gravity is so strong that light is not able to escape it, which makes it invisible to us. So you might be wondering, how do we know where black holes are? And I'll get into that in a minute. So where do black holes come from? National Geographic states the most commonly known way a black hole forms is by stellar death, which means a star is dying and collapses on itself and forms a black hole. And granted, not every star will collapse and form a black hole. It has to be a star that's 10 to 20 times more massive than what our sun is. And so these black holes, they have a lot of gravity and they'll affect a lot of space around them. And one of these ways that they affect space is with these accretion disks. These are, according to theplanets.org, accretion disks are a disk of interstellar material, particles, and gases that spin around the black hole. And this is how we're able to identify and guess locations of black holes because of the behavior it changes in the environment around it. And supermassive black holes are at the center of many galaxies. So you can think of galaxies almost as the accretion disks around supermassive black holes. And these supermassive black holes will pull everything into it and become even more and more massive. It'll pull in planets and just asteroids and even smaller black holes and become more massive. And speaking a lot of gravity, what other effects does gravity have on the environment? This is how we get time relativity. It's one way we get with time relativity. The more massive an object is, will make it warp space and time around it. And this grid kind of shows near the Earth and the Moon how it warps time and space. Helps you get an idea. ScienceNews.org explains Einstein's theory of relativity shows how gravity distorts space and time. And so, what are other theories that affect time? Well, speed also affects time. The faster you're going, the slower time moves for you. Light speed is actually a constant, while time and space are actually variables in that equation. So the faster that we move, time slows down, which this becomes more and more drastic the closer you get to the speed of light. The faster you move at the speed of light, the slower time moves for that object or person. Which might lead you to the question, is time travel possible? And to the future, yes. Physics.org actually says that it would be actually pretty easy as time passes at different rates for people moving relative to one another. So as long as we're either traveling very fast or we're near a very massive object with a large amount of gravity, time is going to move slower for us than it will elsewhere. And according to Adrian Cho, a writer for sciencemag.org, two teams of physicists actually proved this with very sensitive atomic clocks. One stayed on Earth while another was sent into orbit on a rocket. And they showed that these atomic clocks, the atomic clock on the ground ticks slower than the atomic clock that was in orbit, which proved this theory of relativity because of gravity. So this might also lead you to the question, is time travel to the past possible? And as far as we know right now, no. According to physics.org, they say to travel backwards in time, you'd have to move faster than the speed of light, which is not possible as far as we know. So in conclusion, share with you some facts about black holes and time relativity. and I hope you found them as intriguing as I do. Black holes and time relativity are just some examples of the mind-blowing things we've learned about space. So what else is there to learn, and what else is there to discover in space? Well, time will only tell.